What we see here is a basic Vue.js application with a couple of configuration files, of course, but most interestingly to us is the test directory. And in the test directory, we have a couple of subdirectories, for example, the drivers directory, a DSL directory, a directory for all of our specifications, and we have a couple of files for configuration as well, and also helper functions. Let's start with the utils file. And in the utils file, we see that we re-export a couple of functions, and we also export our own custom mock endpoint function. And the point of this utils file is that in our component tests, we don't have to import all of those functions from different packages, but we can import them all from one place. So this means we have some lightweight decoupling, but mostly it's about convenience because we only have to import our helper functions from a single file instead multiple packages. So now let's continue with a couple of mock service worker configuration files. What we can see here is first of all the mock server file, and for our test setup we rely on mock service worker, which is an awesome tool for mocking network requests in the browser, but also in Node.js. And we use this for mocking API calls in our component tests and in our application tests if we run them with Vitest. And in here we simply set up our mock server for Node.js and export it so we can use it in other files like in our utils file, for example. Next, let's take a look at the mock endpoint file. And in the mock endpoint file, we create our own helper function for mocking API requests using the mock service worker library. So with our mock endpoint function, we can simply provide a body, a method, and a status, and then we do the rest in here to use the mock service worker library to mock API requests that match the specifications or the configuration we put in here. The heart of our perfect test setup is the generic driver. So here we see a TypeScript interface or a couple of TypeScript types for a generic driver for our application test framework, basically. So because we want to decouple our application tests from particular test frameworks like Playwright or Vitest in our case, we use our own custom driver interface, or we specify our own custom driver interface. As we can see here, we specify a couple of assertions. We specify that we have a find by label text method, for example, or find by role, and so on. And here we can see everything coming together to form our driver interface. And instead of using Playwright or Vitest functions directly inside of our application tests, we will use this generic driver interface so our tests are decoupled from a particular test framework. So whenever we feel the need to, we can simply swap test frameworks, for example. Imagine that one of the test frameworks we choose at the beginning of our project is not maintained anymore, for example. Thanks to decoupling, we can write a new driver, which shouldn't be too much work, and we don't need to touch all our tests, which might be hundreds or maybe even thousands of tests. So let's take a look at a specific application test example. In our specs folder, we see here we have a single shopping list specification with two tests. And the first test, we say it should be possible to add items to the list. And then we set up a new shopping list object, which is a domain-specific language object, which provides a couple of methods according to our domain-specific language. So as a language specific to the problem domain of our application, which is the problem domain of a shopping list. So basically the problem domain of grocery shopping. And here we have an open method, an add item method, and an expect item on list method. And we can see here that thanks to using a domain-specific language to write our tests, it's very easy to see what's happening here, what's going on here in our test. Even for non-programmers, it would be rather straightforward to figure out what this test is about. So let's take a closer look at this DSL magic. In the DSL directory, we can see we have a shopping list file, and this shopping list file exposes all those methods we saw in our tests. So we have an open method to open the shopping list application. We have an add item method to add items to the shopping list and remove items and so on. And in those methods, we use the driver, which we inject with the setup method on the driver itself. And the driver itself is injected as one parameter of the it function. And depending whether we are running our tests using Playwright or we run our tests using Vitest, this driver implementation will be either a Playwright implementation or the Vitest implementation. So we inject the driver into our shopping list factory, which we can see here in the DSL. So in the shopping list DSL factory, we inject the driver. So we can use the driver in here to build our domain-specific language. For example, for the add item method, we can see that we use the find by label text method on the driver to find an input field with the label title, and then we type in the title of the item we want to add to the shopping list. And after we've typed in the title into the input field, we want to add the item, and therefore we click the button that has the name add item. Okay, so this was the DSL and the driver itself. But now let's take a closer look at how to implement a new driver, for example, for Playwright or Vitest in our case. So in our drivers directory, we have two implementations, one for Playwright and one for Vitest. So let's take a short look at the Playwright driver first. And in here we see, for example, we have assertions, and to build our assertions, we use the methods or the functions provided by Playwright. For example, the expect function, and then we expect for our should have attribute method on our custom driver, we use the to have attribute method on the expect function provided by Playwright. And so on. We do the same for interactions, for example. So we have a click interaction where we use an element resolver, which is basically a locator function provided by Playwright. And then we click on an element, for example. And at the end, we can see here our make driver factory, which builds a new driver that matches the interface we specified for our generic driver, but using Playwright in this case. We use the Playwright page object, for example, and so on. And last but not least, we also see our own custom it function, which injects the driver into the callback function of the test. So, for example, here we have the it function, and the second param is the callback function, and here we inject the driver as a param of the callback function. So much for the Playwright driver. Let's take a short look at the Vitest driver as well. So here we see the Vitest driver, and for the Vitest driver it looks similar. We also have our assertions function where we build our assertions. For example, the should be visible assertion, and here we use the expect provided by Vitest and the to be visible method that we get from the expect function by Vitest. And it's the same for interactions. For example, here the click interaction. We do some magic here because with Playwright we can click multiple elements at once, but with Vitest not. So we implement the same functionality for Vitest as well. So depending if we resolve one element or multiple elements, we always convert elements into an array and then iterate over every element, which might be only one, and click the element or the elements. We do the same for type and so on. And here again we see a driver factory which implements all the methods that we specified on our generic driver interface. The interesting bit here is, or the most interesting bit here, is the goTo method, because our Vitest tests do not run in a real browser. So if we run our tests with Playwright, they run in a real browser, but with Vitest, they don't run in a real browser. This has the benefit that they are very fast because they run in a Node.js environment, and this can be much faster than having a real DOM, but we need to do some magic to make this work with our application. And here we can see the magic that we do. We instantiate a new router, a view router, and we use the view router for navigation. So instead of using the browser APIs to navigate between pages, we use our virtual router or a view router instance to navigate through our application. And then we mount our application into the virtual DOM that we have in the Vitest environment provided by a JS DOM. So much for the most special thing about the Vitest driver implementation. But what you can see is that the two implementations for our Playwright driver and the Vitest driver are rather straightforward. So you can imagine if you want to implement a new driver for a new fancy test framework, you can do it in an hour or a couple of hours top. Thanks to the drivers, our perfect test setup is perfectly decoupled from the test framework, for example. And thanks to the DSL that we specified here, our tests are also perfectly decoupled from the user interface. So because thanks to the DSL, we don't have to specify in our tests that we need to click a particular button, for example. So whenever the user interface changes and the label of a button, for example, changes, or the button becomes a link or whatever, then we only need to change a single line somewhere in our domain-specific language, but we don't need to change all the tests where we have, for example, the functionality to add a new item to the shopping list. So thanks to our perfect test setup, we are perfectly decoupled from the test framework and also from particular implementation details of the user interface. And with that, we are able to quickly write good tests.